Hi future scientists, I am Atom. In this lesson, we will discuss what polar and non-polar covalent bonds are, why some bonds are polar, who's the scientist behind electronegativity, bond polarity as a continuum from ionic bond to polar covalent bond to non-polar covalent bond, guidelines to check for polarity of a molecule, properties of polar and non-polar molecules, and practice questions. That is a big list, so let us get started. What are polar and non-polar covalent bonds, and why are some bonds polar? In a covalent bond, atoms share electrons in order to achieve a stable electron configuration. In a hydrogen molecule, two hydrogen atoms share a pair of electrons to form a single covalent bond. In this example, the electrons are shared evenly by both atoms since they are identical atoms. This is similar to two people sharing a cake equally between them. Hydrogen-hydrogen bonding is a nonpolar covalent bond, meaning no poles are formed or no charge separation is happening between the two hydrogen atoms. Another word for charge separation is dipole. So the dipole moment for a nonpolar covalent bond is 0. The electron cloud is evenly distributed around the two hydrogen atoms. All the diatomic molecules have nonpolar covalent bonds since they are all identical atoms sharing either a pair of electrons like hydrogen, fluorine, chlorine, bromine, and iodine, or sharing two pairs of electrons like oxygen, or sharing three pairs of electrons like nitrogen. In a hydrogen fluoride molecule, hydrogen and fluorine share a pair of electrons to form a single covalent bond. Since the two atoms are different, the electron pair is not shared evenly between the two atoms. This is similar to two dogs sharing a 4-slice cake, where one dog gets 1 slice and the other gets 3 slices. They are sharing the cake, but the sharing is uneven. Why is the sharing uneven if the atoms are different? This is because the electronegativity, or the ability to attract the shared pair of electrons, is different for each atom. Fluorine has the highest electronegativity of all elements of about 4. Hydrogen's electronegativity is 2.1. So fluorine pulls the shared electrons more strongly towards it than towards hydrogen. Thus, fluorine gets a partial negative charge and hydrogen gets a partial positive charge. Since there is a charge separation here, there is a dipole. The direction of the dipole moment can be shown using an arrow with the positive end of the arrow over the less electronegative hydrogen and the direction of the arrow towards the more electronegative fluorine. The electron cloud is attracted more to fluorine than to hydrogen. Electronegativity is greatest for elements on the upper right side of the periodic table and the lowest for elements on the lower left. Within a period, electronegativity increases from left to right. Within a group, electronegativity increases from bottom to top. How polar a bond is can be determined by the difference in electronegativities of the bonding atoms. If there is a big difference in electronegativity, then the dipole moment is greater and the bond is more polar. In other words, if there is a large distance between the atoms on the periodic table, the bond tends to be more polar. List the following covalent bonds from least to most polar: HN, HO, and HF. So if you look at the periodic table, the least to most polar is going to be HN is the least, HO comes second, and HF is the most polar. The scientist behind electronegativity. Linus Pauling, 1901 to 1994, was an American scientist who determined the phenomenon of electronegativity. He is the only one who has ever received 2 individual Nobel Prizes. In 1954, he received a Nobel Prize in Chemistry for his contributions to the study of chemical bonds. Pauling was one of the first scientists to raise concerns about the health hazards of nuclear weapons testing. In 1962, he received a Nobel Prize for Peace for his efforts to promote nuclear disarmament. Pauling's yet another significant contribution lies in his identification of the genetic mutation in the hemoglobin protein responsible for sickle cell anemia, resulting in the abnormal shape of red blood cells. Bond polarity as a continuum. Bond polarity exists as a continuum or a spectrum, or kind of falls on a number line. The nonpolar covalent bonds with equal electron sharing lie on one end of this number line. Ionic bonds with complete electron transfer exist on the other end of this number line. In the middle region, polar covalent bonds exist with unequal electron sharing. Are there specific boundaries between these bonds? If the difference in electronegativity between the atoms is greater than 1.8, it is an ionic bond. The difference in electronegativity between Cl and Na is 3.0 minus 0.9, which equals 2.1, so NaCl is an ionic bond. The metal sodium transfers its valence electron to the nonmetal chlorine, and they become Na1 plus ion and Cl1 minus ion. If the difference in electronegativity between the atoms is less than 0.4, it is a nonpolar covalent bond. The difference in electronegativity between hydrogen and carbon is 2.5 minus 2.1, which equals 0.4, so the CH bond is a nonpolar covalent bond. Here, there is a fairly equal sharing of electrons between carbon and hydrogen. If the difference in electronegativity between the atoms is between 0.4 and 1.8, it is a polar covalent bond. The difference in electronegativity between oxygen and hydrogen is 3.5 minus 2.1, which equals 1.4, so the OH bond is a polar covalent bond. The shared electrons are pulled more strongly by oxygen than by hydrogen. Guidelines to check for polarity of a molecule. Use the periodic table to estimate electronegativity values and calculate the electronegativity difference between the bonded atoms. The greater the difference, the more polar the bond is. HCl. Electronegativity of hydrogen is 2.1, that of chlorine is 3.0, so the difference in electronegativity equals 3.0 minus 2.1 equals 0.9, so HCl is a polar bond. If the molecule has symmetrical geometry and all polar bonds cancel each other out, the molecule is nonpolar. Carbon dioxide has a linear molecular geometry with two oxygen atoms bonded to the central carbon atom. The C double bond O dipoles point in opposite directions, and the net dipole moment is 0. So CO2 is nonpolar. Carbon tetrachloride, CCl4. The CCl bonds are polar, but the molecule is nonpolar because the dipole moments cancel each other out due to the symmetrical arrangement of chlorine atoms around the central carbon atom. If the molecule has an asymmetrical geometry or polar bonds do not cancel out, the molecule is polar. Water has a bent molecular geometry with two lone pairs on the central oxygen atom. The OH bonds are polar, and the molecule overall is polar due to the asymmetrical arrangement of the hydrogen atoms. Ammonia has a trigonal pyramidal molecular geometry. Each NH bond in ammonia is polar. And because of the asymmetrical geometry and the fact that the nitrogen has a lone pair of electrons, it makes the nitrogen end slightly negative and the hydrogen end slightly positive, and the molecule is polar. If a molecule has identical atoms arranged symmetrically around the central atom, it may be nonpolar. CBr4, carbon tetrabromide, has a tetrahedral geometry and is nonpolar due to the symmetrical arrangement of the bromine atoms around the central carbon atom. If a molecule has different atoms around the central atom, the molecule is more likely to be polar. CH3Cl. Unlike methane, here there is no symmetry and the molecule is polar due to the CCl bond. A molecule is polar if it has exactly one polar covalent bond. Example is hydrogen-bromine bond. A molecule is nonpolar if all the bonds are nonpolar. Example is CH4. Each CH bond is nonpolar, and so CH4 is nonpolar. Properties of polar and nonpolar molecules. Nonpolar substances have lower boiling and melting points compared to polar substances. This is because the intermolecular forces in nonpolar substances are weaker and less energy is needed to change their phase. Nitrogen has a boiling point of negative 196 degrees Celsius, while water has a boiling point of 100 degrees Celsius. Polar substances are soluble in other polar solvents because they have partial negative and positive charges which attract each other. Table salt, NaCl, dissolves in water, as an example. Nonpolar substances do not have partial positive and negative charges, and so they do not dissolve in polar substances. Oil is nonpolar, and since it does not have any partial plus or minus charges, they are not attracted to the water molecules. Practice questions. 1. Boron trichloride, polar or nonpolar? Nonpolar. BCl3 is a trigonal planar molecule, which means it is a symmetrical molecule. The boron-chlorine bond dipole moments cancel out, making the molecule nonpolar. 2. Hydrogen sulfide, H2S, polar or nonpolar? It is polar. It has a bent molecular geometry. The difference in electronegativity between sulfur and hydrogen is 2.5 minus 2.1, which equals 0.4. So even though the bonds are not highly polar, sulfur has 2 lone pairs of electrons, which makes the overall molecule polar. Classify each of the following bonds as ionic, polar covalent, or nonpolar covalent. Bond between iodine and iodine, it is nonpolar covalent. Bond between carbon and hydrogen. It is nonpolar covalent because the difference in electronegativity is equal to 0.4. Bond between oxygen and hydrogen, polar covalent. Bond between lithium and fluorine, it's ionic. Lithium is a metal and fluorine is a nonmetal. Bond between hydrogen and chlorine, polar covalent. Number 4, ammonia, NH3, polar or nonpolar? As we discussed before, NH3 is polar. It has a trigonal pyramidal geometry and it is not a symmetrical molecule. Nitrogen has a lone pair of electrons also, so the molecule is polar. 5. CH2Cl2, polar or nonpolar? It is polar. It has a tetrahedral geometry. The carbon-hydrogen bonds are nonpolar, but the carbon-chlorine bonds are polar and the electrons are not distributed symmetrically. There is a net dipole moment in the direction of the CCl bonds, making the molecule polar. 6. H2O2, hydrogen peroxide, polar or nonpolar? It is polar. It has a bent geometry. It is not a symmetrical molecule when you look at its three-dimensional image. The OH dipole moments do not cancel out. Also, the oxygen atoms have 2 lone pairs of electrons. Therefore, the molecule is polar. PCl5, nonpolar. PCl5 has a trigonal bipyramidal geometry and it is a symmetrical molecule. Each phosphorus-chlorine bond is polar, but the dipole moment of each bond cancels out, making the molecule nonpolar. There you have it, polar and nonpolar covalent bonds. If you would like to see more science content explained in an accessible way, please consider subscribing, sharing, liking, and supporting. Your support enables me to create more educational content. Happy learning. Thank you.